So the Frank slide, type of disaster. So the Frank slide was one of Canada's largest rock slides, which buried parts of the town Frank in Alberta. The slide was a translational mass wasting event, meaning that the mass of rock moved across a planar surface with little rotation. Rock slides are one of the most dangerous forms of mass wasting, as they are very fast-paced releases of bedrock along a uniform plane that will certainly take out anything in its path and travel relatively long distances. And the picture to the left shows the town right before the slide, and the picture to the right shows the town one day after the slide. And you can just see in the background what looks like half of Turtle Mountain missing and a huge talus slope at the base, which is covering parts of the town, as well as a huge dust cloud. So where exactly did this happen? So the town of Frank was founded in 1901 at the base of Turtle Mountain in Crow's Nest Pass after coal had been discovered close by. The Canadian Pacific Railroad runs directly adjacent to it and helped populate the town to 600 residents by the time of the disaster. Although the Canadian American Mining Company deemed the mountain stable to mine, the Blackfoot and Kootenai peoples who lived close by to the area for years called Turtle Mountain the mountain that moves and refused to camp in its vicinity. So the picture to the right shows where the coal seam was and where they were mining, as well as the railway. And the picture to the left shows a map of the slide and the adjacent cities, and it just kind of puts into perspective how far the rocks moved and the huge area covered. And Frank actually used to be closer to the mine, but a few years after the disaster, engineers saw the mountain was still moving and chose to move the town farther away. So what happened? On April 29th, 1903, at 4:10 a.m., 82 million tons of limestone broke off the east face of Turtle Mountain and roared down into the valley. The rock slide took with it all parts of the mine's buildings, 1.2 miles of railway, and a part of Frank. Of the town's approximately 600 inhabitants, almost 100 were in the path of the slide, which took an estimated 70 lives. Witnesses of the disaster claimed that it took about 100 seconds for the slide to reach the opposing hills. And the mass of rock traveled at a speed of about 70 miles per hour. The train below narrowly avoided the disaster and sped out just in time. 17 miners were trapped underground but managed to cut a path through the rock and emerged 13 hours later. So the picture to the right shows exactly what broke off the mountain, and as you can see is basically just the two highest peaks just gone and half the mountain destroyed. To the right, this is a view of the slide from Turtle Mountain, and it shows how far the rocks travel through the valley and uphill to the other side. The tiny little cars on the highway just put into perspective how huge this was.
All right, now that we've laid down the basis for what happened, let's talk about why it happened and the causes. So first, let's talk about morphologic causes. So Turtle Mountain was a relatively unstable structure, and this instability stemmed from the fact that it was located on a major thrust fault called the Turtle Mountain Thrust Fault. Now, the reason that being located on a thrust fault make it unstable is because as the plates push together, it causes the horizontal layers of rock to compress and become positioned vertically, more and more vertically until rock eventually starts toppling over, which is what happens when a rock slide happens. Now moving on to geologic causes. The composition of Turtle Mountain is essentially as follows. So we have heavy and hard limestone sitting atop of relatively light and soft sandstone and shale. So obviously, just by nature of that, the mountain isn't that stable because it's a heavy mass on top of a light mass. Now we take into account the climate of the region, which during the winter tends to freeze and melt ice. Now, this is because of obviously temperature fluctuations. And when moisture, so any sort of precipitation, seeps in through the hard limestone, it freezes, which obviously expands the water. It freezes when the temperature gets cold. And then once again, when the temperature warms up, more water seeps in. And then as this freezing and melting keeps occurring, it further destabilizes the rock and makes it even more unstable. And now moving on to anthropogenic causes. So essentially, what humans have done conducive to the rock slide. Mining. So as we spoke about previously, Turtle Mountain was a pretty heavily mined structure, and essentially coal mining led or slightly led to the rock slide occurring. Now, scientists at first thought that this was a major reason, but then they further concluded that it wasn't the biggest reason as to why the mountain or there was a rock slide in the mountain. It was merely a contributing factor, but the mountain was poised to fall, or the mountain was poised to have undergo a rock slide regardless. This just may have sped up the process. And now here are some statistics just to depict the magnitude of the event and how dangerous a rock slide can be. I'll pretty much summarize by the death toll, which is 70 to 90 people, and by some estimates, even more. Now, because of such a significant event, this did leave behind a legacy. So following the rock slide, the population in Frank increased to around 1,000, but then eventually the coal mine closed down, after which the population dropped and to around where it is now, which is around 200. The site has recently been designated a provincial historic site of Alberta, which is just a designation given to a historic site in the province of Alberta. Pretty self-explanatory. And then finally, a museum was built at the site. Thank you.